Hello everybody. We are discussing from today the concepts of physics which are needed for us at intermediate first year level. In fact, all of you people are having an idea like a sort of a phobia, I should call it. Physics is very tough, difficult or whatnot. But it is not going to be like that. If you just go through physics in a proper way, like in the sense by taking suitable examples which are needed for us and which we people are observing in everyday life, then definitely physics is going to be one of the easiest most and scoring most subjects at intermediate junior level. So in fact, we people are having several chapters in first year intermediate. Out of all, the main concepts what you people have to discuss and remain rather in your memory, that is related to mechanics part. Maximum part of physics of first year is totally based on mechanics, particularly the motion of a body along a straight line, motion of a body along a plane. Likewise, we people are having Newton's laws of motion, work, power and energy, and so on and so forth. Different chapters. And second part of intermediate first year syllabus, if you take up, that is heat and thermodynamics. These are the areas what you are going to read for the examination, final, that is intermediate junior examination as such. But if you look at this first part, that is motion in a straight line, that is a chapter which we people are discussing today in a detailed manner. Every one of you are aware of the pattern of the question paper at intermediate level, both in first and second years as well. You will be given very short answered questions, around 10 by number. And of course, all 10 are to be answered without having any choice, without leaving any question. That is important to be noted here. And each question carries 2 marks for you. That in the sense, 10 questions, 10 into 2, that is costing 20 marks for you in the final examination. Exactly in the same manner, we will be having short answered questions, SAQs in short form, we people used to give. What are these SAQs officially? We will be given around 8 questions. Out of them, 6 are to be answered. That in the sense, 2 questions you will be having in choice like. Any 2 of your choice, of course, you can leave them if you are not confident about their answers. But 6 questions you people have to answer. Out of the 6 questions, each question that carries 4 marks for you. That in the sense 6 into 4, 24 marks you can obtain directly from short answered questions, SAQs. 24 plus very short answered questions, 20 marks, total 44 marks over here. After that, you will be given long answer questions, LAQs in short form we used to call. Out of all the LAQs, 3 questions will be given. Out of them, 2 are to be answered. In the sense, there also you will be having a choice of 1 question. Out of them, if you just leave 1 and answer 2 of the remaining, then you will be getting 2 into 8, 16 marks in all. 16 plus 24 plus 20. Put together 60 marks as such. That is the pattern what of course we people are having at intermediate level, both in junior as well as senior levels I am talking about. But out of all, usually every student feels it easy to answer long answer question and even short answered questions, because they are direct questions taken from the textbook usually, and most of the questions will have answers also directly taken from the textbook as such. Likely you may be having a derivation type of a question, or you may be having an experimentation, or simply some sort of a descriptive type of a question. These types of questions you can expect in SAQs and even in LAQs. But the very important most aspect of intermediate examination is regarding very short answered questions, VSAQs in short form, which of course each question will have 2 marks for you. But generally, students used to write very lengthy answers for these questions. That is not necessary also. All of you should underline these points carefully. One is this: you need to write either 2 sentences or 2 phrases, or simply the problem related question. If it is, you just have to write the steps and show the correct answer with its units. Don't go beyond this. Don't waste your energy and time in writing essays like for a 2 marks answer. That in the sense, 2 mark questions which are called very short answered questions, writing them is an art also. What for I am calling it as an art, you all can understand. The question you should read thoroughly first. You should understand the question. After understanding the question, what is the answer for that, you write that one in a capsule manner. Capsule manner in the sense, you need not write pages together the answer for that question. Even if you write one very long page for one answer, out of the entire description, the 2 words or 2 sentences which are the answers for that particular question, if you are missing them, you will not be given marks for that one at all. That in the sense, whatever the question that is given, related to that, the correct answer is to be produced in a very short or a capsule manner. That is very, very important for every one of you to remember. That in the sense, reading the question is an art over there, I have told you. After reading, understanding is the second criteria. What is the question that is asked? Exactly write the answer to the point. That is the third aspect of it, every student should have in memory. And out of the 10 VSAQs, every year it is like this, at least 2 to 3 questions he used to generalize and give them in the exam. What do you mean by generalizing? Like the one which we people are seeing in our daily life. There are so many aspects which we people are seeing every day in our daily life. Out of them, every aspect is somehow or the other related to physics. That means you should not simply read or mug up the questions and answers in the textbook. You even should have some general thinking about that particular concept also. That will certainly fetch you answer all the 10 questions to secure 20 marks in full. And for example, if you look at the total marks of physics paper in intermediate level, 60 on 60 if a student wants to get, he should be perfect and thorough with only very short answered questions. Otherwise, that student will be stopped at either 54 or 56 or 58. Suppose one question you could not write well, then naturally you will be losing 2 marks. That means you will be stopped at 58 only. If 2 questions of such kind you have lost, you will be left at 56. That is the way you people just have to look into. In the sense what? Every bit of it is very, very important. And writing the correct answer is equally important over there. As I have already told you, capsule way of studies, capsule way of writing the answers in the examination, that is really going to fetch you a lot. These are the points everybody have to remember before just going for the final examination in intermediate first year or second year in final exam 2014. That's the point. But before taking up, how to just tackle the 2 mark questions, how to write the answers for 4 marks, that is short answers, and even what answers we people have to write at LAQs also, long answer questions, like all these things in a very detailed manner we people are going to discuss in this course now. So if you start with one chapter, like we are having motion in a straight line, for example. Motion in a straight line. What is this concept? First of all, this chapter clearly deals with the way a body used to move along a straight line path. That is important. Along a straight line path is also called linear motion of a body. That is what we are discussing in a detailed way in this particular chapter. And overall, the bird view of this chapter, if you take up, what are the concepts you are going to deal with? Mainly this chapter contains What do you mean by rest position? What do you mean by motion of a body? And what exactly is called distance travelled by the body, and what is the displacement of the body? What is speed? What is velocity? And what are the different types of speeds we have? For example, uniform speed, non-uniform speed, instantaneous speed, and average speed. Exactly in the same manner, uniform velocity, non-uniform velocity, instantaneous velocity, and average velocity. Such kinds of or types of velocities we are going to discuss in this particular chapter. After that, we are concentrating mainly on acceleration and retardation, which is also called negative acceleration or deceleration of a body as such. So, when a body is having linear motion, how can we just calculate its velocity? How can we estimate its acceleration or retardation? These are the areas overall we people are going to discuss in this particular chapter. So, if you look at this particular topic as such, main concepts one has to remember are the equations of motion of a body. For example, if you just take equations of motion, there are 4 major equations of motion of a body which all of you are familiar with them. I just remind you, V is equal to U plus AT. That is the relation between initial and final velocities, uniform acceleration of the body with respect to time. V is equal to U plus AT. That is the first equation of motion what we people are going to have. And the second equation, if you recollect, S is equal to ut plus half at square. That is the equation what you people are having as second equation of motion. What is this equation? I repeat once again. S is equal to ut plus half at square. If you just look at this equation carefully, what is the missing term? Identify that one carefully. What is missing there? Final velocity is missing there. V is not there. So, what is this particular equation giving us? It gives us a relation between displacement, initial velocity, acceleration uniform value, and time taken by the body to travel that much of displacement. That is actually the equation second. If you take the third equation, V square minus U square is equal to 2AS. That is the third equation of motion. V square is equal to U square plus 2AS. You can write it like that. What are what once again here? Identify what is the letter that is missing first of all. In this equation 3, we are not having the time term at all. That in the sense, even without knowing the time, one can relate initial velocity, final velocity, uniform acceleration of the body with its displacement there. So, V square minus U square is equal to 2AS, or V square is equal to U square plus 2AS. That is the third equation of motion for you. Exactly in the same manner, the fourth equation what we people are having, try to recollect that one. Sn is equal to U plus A by 2 into 2n minus 1. I write that equation once again. Sn, what is this Sn indicating over here? It is the displacement of a body in nth second. All of you are familiar with this terminology. What do you mean by nth second here? For example, I just want to calculate the displacement of a body in 5th second. That may be traveling for 10 seconds. Or that might be traveling for 20 seconds. I don't want all those. What I just want in this particular case is, in 5th second, what is the displacement of the body? That time, I can make use of this equation. That is what is called S5 that time. That 5 stands for the value of n. nth second, that in this example what I gave you will now be 5th second as such. And what is the relation you people are getting in this equation? You can calculate displacement of a body in a particular second, that in other words we can say this one is as well equivalent to the instantaneous velocity of the body. Sn is equal to u plus a by 2 into 2n minus 1. Out of that, u stands for initial velocity, a stands for uniform acceleration of the body. So before taking up the chapter, that is motion of a body along a straight line, one should be completely thorough with these 4 equations as such. Based on that only, we people are going to deal with this total chapter as such. That is one. And remember one more concept here carefully. In all the 4 equations, you are having a letter A. What is that A there? It is uniform acceleration of the body, not non-uniform acceleration. Remember that point carefully. If the acceleration of the body is non-uniform by any chance, then no equation out of the 4 is valid for that particular body. That in the sense what? Unless until the acceleration or retardation of the body is uniform, you cannot apply these equations for any body of such kind. That is the point you should understand. That in the sense acceleration of the body should be uniform, then only the equations are valid for us. So main concept of this chapter is totally depending on these 4 equations, which all of you might be thorough with every equation what I have just explained you here on the board. So we're taking this concept, let us now take up how can we write the answers for very short answer type of questions. I have already told you, very short answer type of questions, you need not write big answers for them. Just 2 sentences, simple description, 2 simple phrases, enough for you. That will certainly fetch you 2 marks for each question over there. So let us now take up those questions at the end of the textbook chapter, that is in the exercises. What are all the very short answer questions they have provided? We are going to discuss the answers for each and every question, whatever we come across now. That is the point. So let us start with the first question from the chapter, motion of a body along a straight line, VSAQ number 1. A very important question this one is, and a very interesting question as well. The states of motion and rest are relative. Explain. State of motion and state of rest, these 2 are relative. What is the concept behind? First and foremost, you should understand from this question, what do you mean by the word called relative? Relative word we use only when we compare 2 different aspects. For example, a person is taller than another personality. When I say, it is understood the first person is tall relative to the second person. That means whenever we are comparing 2 different bodies, whenever we people are comparing 2 different physical quantities, we people are taking this particular word called relative. In fact, we know according to the basics of mechanics, relative terms are both motion and rest. Motion means a body is in motion, of course we used to say. When it is in motion, in moving condition, we can say the body is in motion. But with respect to which other body it is in motion, we have to think of. For example, if you are going by a train, you are sitting inside the train is just running with some speed. Then if you feel what is your motion with respect to a person sitting behind you? You are having your friends also sitting along with you. In such case, what is your velocity with respect to your friends whosoever are traveling along with you sitting behind? You will feel that with respect to your friends, you are at rest. That means you are not running inside the train. You are sitting quietly there, but train is running. When train is running, no doubt every one of you will run with the same speed inside the train. But with respect to your neighbor, you will be seeing as if neither you are moving nor your neighbor is moving. That means what? Your position is relatively at rest with respect to the co-passengers. Whereas when you talk about your motion for a body outside the train, that means the sense a person is watching you and the train standing outside the train, then what you will find? That fellow finds that you are moving along with the train. That means what? Reference to the point. That means we used to take a relative frame of reference there. With respect to the reference frame, one should say whether a body is in motion or at rest. So automatically the states of motion and rest are relative. Explain is the question. So 2 sentences you can write. Very simple. What is the first sentence over there? When we are traveling by a train, with respect to the co-passengers, we will be at rest. Similarly, with respect to a person observing the train from outside the train, we are in motion. That means when we are taking 2 different frames over here, one frame with respect to the first frame, you are at rest. With respect to the second frame, you are in motion. So automatically one can say that these 2 terms like motion and rest are relative to one another. I think all of you might have got the correct answer for this. So you should write 2 sentences. I repeat once again. When we are going by a train, with respect to the co-passengers, we are said to be at rest. Whereas with respect to a person outside the train, we are in motion. Therefore, motion and rest are relative to one another. Just 2 sentences, if you write like that, you will be given completely full 2 marks for that. But one thing you should understand, first when you write motion, what is motion and what is rest? Like if you give 2 examples, 2 marks they will directly give you. So the question 1 has got simply a 2 sentence answer. That is the one what one has to remember. I hope all of you have followed this concept. A wonderful concept to know. Let us take the second question over here, please. How is average velocity different from instantaneous velocity? First of all, you need to know every definition whatever is given in the textbook. What do you mean by average velocity? How is average velocity different from instantaneous velocity? The question. So if you give first of all the definition for average velocity and the definition for instantaneous velocity, you will be given 1 mark for that one first. Then what is the difference if you can give in 1 sentence, you will be given the 2nd mark also for that. That in the sense both the marks you can get for this particular answer. First and foremost, what is average velocity? Average velocity, you can define it like it is the total displacement of a body covered in total time taken. Total displacement by total time, that is what we call it as average velocity. But by the time you write this definition, you can identify the nature of it. What is that nature there? This particular average velocity can never give the complete idea about the motion of the body. Average values will never be close to the realistic values. We know that one very well. Therefore, it is not going to give us the correct idea about the motion of a body. Therefore, average velocity, you can give the statement like this. It is the total displacement divided by total time taken. That is the concept. What is instantaneous velocity? The velocity of a body at a particular instant of time. Means what? This gives more about the motion of the body. So, how do we write these two formulae? I will just remind you here. If you just observe this average velocity part of it first. Average velocity can be given as total displacement by total time. Total displacement by total time taken, when can we consider? When the body is having motion in a zigzag manner, like it may be having uniform velocity for some time, uniform acceleration for some other time, uniform retardation for some other time. If its motion is not uniformly or properly maintained, then we can calculate average velocity. So, what is the conclusion you should have? What is the difference means? What you should understand? Average velocity can never provide the correct way of motion of the body. Whereas instantaneous velocity, we people used to write like this: limit delta t tends to 0, delta s by delta t. It is the smallest displacement of a body covered in smallest period of time, delta s by delta t. Limit delta t tends to 0. That is the concept what we have to take up. So, you have to give first of all both the definitions. Average velocity is defined as the total displacement of the body covered in total period of time. And you should write the formula. Instantaneous velocity, it is limit delta t tends to 0, delta s by delta t. After writing both the formulae, you should give one sentence as the difference. Average velocity of a body cannot provide the correct way of motion of the body. Whereas instantaneous velocity can tell you up to certain extent how the body is moving at that particular instant. This is the difference you just have to give. So, that is the way in which you can score 2 marks for this. Both the definitions you have to give and one sentence you should tell the difference. What is the difference? Once again I repeat, average velocity cannot provide the correct way of motion of the body, whereas instantaneous velocity can provide the way in which the body is in motion at that instant. That is the difference you have to give. So, this is the second question given in our textbook. Right, just let us take the third question like, give an example where the velocity of an object is 0, but its acceleration is not 0. In fact, such a type of concepts you need to think before writing the correct answer for that. First and foremost, will there be any possibility for a body to have 0 velocity and still it is accelerating? Generally, when you think in general terminology, you may say it is not possible. But from physics point of view, when you discuss, certainly it is possible. What is the concept behind? I will just give you. When a body is thrown up vertically with a certain velocity u, then naturally the body reaches the maximum height there. After reaching the maximum height, what happens to its final velocity? Certainly final velocity will be 0. But one should understand the body is still under the influence of acceleration due to gravity. The body is still under the influence of acceleration due to gravity. What do you mean by that? Body's velocity is 0, but acceleration is not 0. It is equal to acceleration due to gravity. So, if a body is thrown up vertically with a certain velocity u, for example, then after reaching the maximum height, certainly its velocity becomes 0. That is the reason why it is stopping there. Otherwise, it would have gone further up. It is not going up. That means what? Its velocity has become 0 there. Fine. But body will certainly be having the influence of acceleration due to gravity. In which direction that acceleration due to gravity that is going to act? It will be acting downwards there. That means what? Even though the velocity of the body is 0 at the highest point, its acceleration is not 0. Its acceleration is equal to what? Acceleration due to gravity. So, how to write the answer for this question? You look at once again. Give an example where the velocity of an object is 0, but its acceleration is not 0. That is the question. So, you should write it like this. When a body is thrown vertically up with a velocity u, at the maximum height reached by the body, its velocity becomes 0, but acceleration is not equal to 0 and it is numerically equals to acceleration due to gravity acting in the downward direction. That is the correct answer for this. I repeat once again, when a body is thrown up vertically with a velocity u, after reaching the maximum height, its final velocity becomes 0. But its acceleration is not equal to 0. It is numerically equals to the acceleration due to gravity in the downward direction. That is the concept. In fact, this question can even be asked in a different way also. He may question you this way. Can the velocity and acceleration of a body are opposite by directions? I repeat once again. Can the velocity and acceleration of a body be opposite by directions? Of course, yes. Yes, in what way? When you throw a body up vertically, while going up, velocity's direction is vertically upward. Whereas, acceleration due to gravity's direction is vertically downwards. That means what? Both V and G are opposite by directions. So, same question can even be asked in that manner also. So, the correct answer for this one, velocity and acceleration can be opposite by directions. And second thing is, velocity at the highest point will be 0, but acceleration is equal to acceleration due to gravity acting in the downward direction. That is the correct answer for this question as such. That is question number 3. Let us take the fourth question here. A small derivation he has asked, which is a very, very important equation for you. A vehicle travels half the distance L with a speed V1 and the other half with a speed V2. What is the average speed? That is the question asked. Half the total distance with speed V1, remaining half with a speed V2. What is its average speed? That is the question. Let us just take up this way. There is a body which is traveling a distance L like this. This is the total distance what we people are having. Let us consider half the distance L by 2, L by 2. First half, second half. First half of the distance, it is traveling with a speed V1 that is given here. Second half of the distance, it has travelled with a speed V2. So, one can directly understand this value like this. L by 2 distance with a velocity V1. remaining L by 2 distance with a velocity V2. So, L by 2 distance with V1, L by 2 distance with V2. These two are the values what have been provided in the problem for us. It's in fact like a problem we can take up. When we talk about L by 2 distance with a velocity V1 if it is traveling, how much time it is taking to travel that much of distance? I repeat, how much time the body is taking to travel L by 2 distance, I calculate first. Time taken by the body to travel L by 2 distance, T1 if I take it, it is equal to distance by velocity. All of us we know time is equal to distance by velocity, that is the formula. Distance L by 2, velocity V1. So, distance by speed also you can call it L by 2 by V1. Which is written as L by 2V1. That is the time taken by the body to travel L by 2 distance as such. Exactly in the same manner, how much time the body is taking to cover the second half of the distance, let us take up. If I take that time as T2, that is again distance by speed. What is the distance in this case given? L by 2. What is the speed that is given here? V2. So, we can write L by 2V2, that is going to be the time taken by the body to cover the second half of the distance. So, first half it is covering in this much of time, second half it is covering in this much of time. But what is the question that is asked? You look at average speed of the body we just want. Average speed already we have discussed as the total distance travelled by total time taken. Total distance travelled by total time taken. So, simply speaking, L by 2 plus L by 2, that will be the total distance travelled. In fact, L by 2 plus L by 2 is nothing other than L only, that is the total distance by total time taken. What is the total time taken here? T1 plus T2 we should write as the total time taken. What is T1 we know, what is T2 we know. Just substitute those two and simplify. See the step carefully. L by 2V1 plus L by 2V2. If you simplify this, you get 2V1 V2 by V1 plus V2. So, if you simplify this one, L getting cancelled. You will be getting 2V1 V2 by V1 plus V2. So, what is the average speed of the body when it is covering half of the distance with a speed V1 and half of the distance with a speed V2? That is a question. When V1 and V2 are the speeds given, L is the total distance travelled by the body. Then average speed of the body becomes 2V1 V2 by V1 plus V2. So how these people used to allocate 2 marks for this type of a question? First, if you write this formula, you will be given 1 mark for that. That means first of all, you should be perfect with the formula. Formula fetches you 1 mark straight away. And substituting the values and simplifying for this formula final what we have got, the remaining 2nd mark of course will be given to you. One of the best questions we have, and the same formula, I repeat, has been asked around 3 to 4 times even at EAMCET level also. So that means the formula, if you are thorough with at intermediate level, certainly this will fetch you while doing some problems at higher levels like different entrance examination levels. That is actually the concept of question number 4. So I hope all of you might have followed the correct way of answering this question 4. Total distance by total time taken, that is average speed. Total distance is L. Total time is of course T1 plus T2, what we people have written as the steps. Substituting the 5 values and simplifying, we get 2V1 V2 by V1 plus V2. That is going to be the average speed of the body. That is the answer for the question number 4. A lift coming down, question number 5 we are taking up. A lift coming down is just about to reach the ground floor. Taking the ground floor as origin and positive direction upwards for all quantities. Which one of the following is correct? Usually such type of questions we expect at entrance examination levels. Like at EAMCET they can ask. At JEE they can ask like this type of a question. At different other entrance examination levels we can expect. But they have given this type of a question at intermediate level. That too junior intermediate level. So it means one need to have the complete and thorough understanding about the subject. Then only one can straight away answer such type of a question. In reality, that answer is not to be calculated here. Simply you should understand and write and choose the correct option out of the 4 options given to us. One is A, B, C and D. If you just look at first of all, what is the convention we have to follow for this? He is talking about a lift is coming down, fine, towards the ground floor it is reaching. Taking the ground floor as the origin and positive direction upwards, that is the concept. If I just take this is the ground, according to the given problem, all the quantities in the upward direction are to be taken positive. That means what is the general concept here? All the quantities which are taken in the downward direction are to be taken negative. Simple logic it's. The concept is quite simple. What we people are talking about is it is coming down, fine. When all the values taken in the upward direction are positive, then all the quantities which are taken in the downward direction are to be taken negative. It is understood. So now observe carefully, lift is coming down all the way, but downward directional quantities are to be taken negative. Negative in the sense, what is understanding? You people can understand 0 if I take as the middle value, all positive numbers you will be having towards your right and all negative numbers you will be having towards your left. So negative value means one should understand it should be less than 0. That is the concept. Negative value means it should be less than 0. That is the understanding. If you have that one, you will directly get the answer. What is the correct answer over here? Correct answer is the first one. A is correct. Look at how. While coming down, displacement will be negative. Observe the wording carefully. Displacement negative. Why negative? While going up, you take positive, he has mentioned in the problem. While going up, taking positive means what? While coming down, take it negative. It is understanding. When you take downwards, it's moving, displacement will be negative. Displacement negative means what you know? It should be less than 0. That is the understanding. And velocity also should be taken negative. Because velocity is a vector which directly depends on displacement over here. So automatically we can say that x velocity, that is v, in this particular case also should be taken less than 0. But one condition you people should understand. The convention for acceleration due to gravity. While coming down, g will be taken positive. While going up, g will be taken negative. All of you are familiar with this convention as far as acceleration due to gravity that is concerned. Now the lift is coming down. That means acceleration should be taken positive. Acceleration means which one it is? Acceleration is nothing other than acceleration due to gravity that is taken positive. If it is positive, very clearly you can say that acceleration is greater than 0. Just observe once again carefully. While going up, what are all the displacement, velocity you have? Take them negative. Take them positive according to him. While coming down, displacement and velocity, you take them negative. So the lift is coming down, moving towards the ground floor. Therefore, its displacement will be taken negative, velocity will also be taken negative. Then what you can understand here is, when displacement is negative, x can be written less than 0. When velocity is negative, v can be written less than 0. But according to the convention, while coming down, g should be taken positive. While going up, g should be taken negative. Therefore, the acceleration so-called, which is equivalent to acceleration due to gravity, that should now be taken positive. That is, taken positive means certainly you can understand a should be greater than 0. Just look at all the 4 options what he has provided you. X less than 0 should be there. V less than 0 should be there, A greater than 0 should be there. Out of all the 4 options, the first option is having all the 3 conditions what we have written here. So certainly the correct answer for this one is A. So A is the correct one for this particular question. So such type of questions generally we expect it, this rather objective model like options, 4 options they will give, multiple choice type of questions like. But such type of a question has been given at first year intermediate for you. Not a difficult one, but one should understand the convention carefully and thoroughly for this particular question number 5. I hope you might have all got the correct option for this particular question. Let us check the 6th one. A uniformly moving cricket ball is hit with a bat for a very short time and is turned back. Show the variation of its acceleration with time, taking the acceleration in the backward direction as positive. Important most concept to be noted is that usually when a cricket ball is just striking a bat and coming back, if you take while going towards the bat it is positive, while coming back it should be taken negative. But according to the given problem, while coming back he is asking you to take its direction as positive. Then while going towards the bat it should be taken negative. That is a concept. So first of all, the body is accelerating because when you just bowl the ball to the batsman, certainly you give so much of force to that, providing greater momentum to that ball to move towards the bat. And he is asking you just to tell what kind of a graph that is to be plotted, nothing else. While moving towards the ball, towards the bat, you can just get a curve this way. What for means it is increasing gradually, the velocity is going to be increased, the momentum is going to be increased. That means the body totally is going to be accelerated there. But what is happening afterwards? If I just take velocity versus time graph like, it directly now comes down. Coming down means what? While coming back, one should take positive. That is actually the idea. So, what is the graphical representation for that? That is the question he is asking. Very simply speaking, while moving towards the bat and while coming back from the bat as such, what exactly? Show the variation of its acceleration. That is the concept. So, the variation of acceleration is going to be in the reverse direction while striking the bat and coming back. So, this particular question hasn't got much of an explanation. You need to just give what kind of a graph you can expect from this. When we people are talking about velocity versus time, in what manner that is accelerating and in what manner it is coming back. So, this first curve while going towards the bat and second one while coming back from the bat as such. But one thing you people should remember here, while moving towards the bat, even you need not have this curvature maximum also. Even if you draw it like a straight line also, one has to accept the fact. Because you are making the acceleration of the body increased gradually. That is the concept behind. So, this type of a graph if you can provide for that particular question number 6, that itself is the correct answer for that. No need for you to just explain lots and lots for this one. What you need to know is you can give OAB like something. OA and AB. OA is while taking the ball moving towards the bat and AB while going back from the bat. Like that you people can explain, that itself is enough for you. Main concentration is on the graphical representation, nothing else for this question number 6. Question number 7 we have. Give an example of one-dimensional motion where a particle moving along the positive x direction comes to rest periodically and moves forward. In fact, I should say this type of a question long back they have asked in JEE examination. That model question they have taken and they have created a simple question at first year intermediate level. What exactly is the concept behind it? Try to understand the wording carefully what he has given. Give an example, fine. Of what? Of one-dimensional motion of a body, where a particle moving along the positive x direction, it is moving towards my right, it is understood, comes to rest periodically. Periodically means what? At regular intervals of time, after 1 second, 2 seconds, 3 seconds, 4 seconds like that. But at the same time, it is coming down to rest and moving in the forward direction. That means what? It should not retrace its path back. That is the idea. So, for such a kind of a thing, one should have a general concept in memory. Which type of an equation that can give us a periodic motion and a forward moving body? Periodic motion of a body is a must there and the body should move in the forward direction. Two things we have to understand. Suppose if I say x is the displacement, that is in terms of t. Displacement in terms of t means what? Displacement as a function of time I am writing. If this is equal to t minus sin t, for example, an equation like this, when I write t is going to be the time and sin is the function, sin t also is another functional time what we people are taking up here. So, if I take xt is equal to t minus sin t as the equation where x is displacement as a function of time is equal to t minus sin t. Such equation if you write here, if t is 0, then what happens? Total value will be 0. It is very clearly understood. If t is 1, for example, then also you will be getting, if t is something like 1, you can write sin 1 here. Sin of small angle can be neglected. We know that one very well. So, naturally, we can just write this one as a t itself, t is 1. So likewise, when time function varies, then automatically the displacement of the body also going to be varied in such a way that the conditions mentioned in the question are going to be hold good. That means the body should move along positive x-axis, that is true, and it comes down to rest periodically, and finally it should move forward. So such a type of equation only can explain the motion of the body what has been given or explained in the particular question number 7. So one should say that the equation for displacement in terms of time or as a function of time, if xt is equal to t minus sin t, that type of an equation only can explain the conditions for the body to move along x direction and coming to rest periodically and continuously moving in the forward direction. So, seventh question is more or less like an equation oriented question, like one need to know to write such a type of equations for this type of a question as such. So, that is the answer for this question number 7. The next question also, he is just giving an applicative type of a question. That means people can easily understand now after looking to 8 questions in succession. All questions are not alike. All of the are not going to have the same standard also. Sometimes the standard is a little higher, more of applicative type than writing the equations and solving the values like. If you look at this question number 8, you can understand how much of understanding or applicative type of thing you need to have. An object falling through a fluid is observed to have an acceleration given by A is equal to G minus BV, where G is the gravitational acceleration and B is a constant. After a long time, it is observed to fall with a constant velocity. What would be the value of this constant velocity? That is a question he is asking. A is equal to G minus BV, that is the concept he has given you. Observe carefully first of all. A is given as acceleration of the body. G is given as acceleration due to gravity. B is like a constant it is given. V is the velocity of the body that is given. So all 4 terms first of all you people should have in memory. Once again I repeat, A for acceleration, B is a constant, G is acceleration due to gravity and V is the velocity. While reading the question, if you are a little careful in understanding the meaning of it, you can identify the correct concept based on which you can answer this question. Look at the second sentence carefully. After a long time, it is observed to fall with a constant velocity. That is the clue for this particular question. Observe the wording carefully. Constant velocity. When will the velocity of a body be constant? When will it be constant? Simple. When velocity is constant, it is understood its acceleration should be 0. Whenever the body is not accelerating but still in motion, then one can say the body's velocity is uniform. So any body whichever is moving with uniform velocity will have 0 acceleration. That is the concept here. So if you can understand this theoretical concept, you will get the answer straight away. In what manner? Look at, velocity is constant, that implies acceleration is 0. Then acceleration which is given in the problem as a G minus BV, that should be 0. He has given you acceleration equation only there. And that acceleration when it is 0, automatically I can write G minus BV must be 0. Then G is equal to BV. What is his question? What is velocity is the question. What is that constant velocity of the body? He is asking you to write that or calculate that. What will now be the velocity? Velocity must be equal to g by b as such. So only point one should understand in answering this question is constant velocity. If you can understand constant velocity concept thoroughly, it is not a question at all. When the body's velocity is constant, it is understood the body has zero acceleration. That means it is not accelerating. It's a very, very clear-cut indication there. Then put this acceleration equals to 0 and find out the value of v, which is g by b as such. That is the answer for the question number 8, what we people are having in very short answer type. Look to the question number 9. If the trajectory of a body is parabolic in one frame, can it be parabolic in another frame that moves with a constant velocity with respect to the first frame? If not, what it can be? What can it be? That is the question. But all of you can understand 2 points here, please. Suppose a body is dropped from an aeroplane. A bomb is dropped from an aeroplane. Which is just flying at a vertical height h. Then what you should understand? When the body is dropped from it, body traces a parabolic path to reach the ground. What is the reason for that also we are aware of? Aeroplane will have certain velocity which is said to be constant. Then automatically the trajectory of the body which is moving towards the ground will be parabolic. Fine. For whom it is parabolic? For a person looking to the same event from outside the frame of the aeroplane. Outside the frame of the aeroplane means what? When I am standing on the ground somewhere here, and if I am looking at that event, I will find that the trajectory of the body as a parabolic path. Fine. But what this pilot used to observe? When you talk about the pilot, when the pilot comes over here, that aeroplane comes over here, he feels the body will be here down below the aeroplane. When the aeroplane comes over here, he feels the body is here down below the aeroplane. What is the reason? Simple reason. Horizontal component of this body, the projectile, is equivalent to the horizontal component of velocity of that aeroplane as such. Means what? Aeroplane's horizontal velocity and the body's horizontal velocity both are one and the same. Therefore, the pilot feels as if the body is tracing a straight line path to reach the ground. So, based on almost this logic, they have asked you this question. So, what is the answer you can write for this? All this description you need not write there. It is only an example I have provided you so that to make you understand what exactly is frame of reference and what exactly is meant by the path traced by a body. So, all this is not necessary for you. What you need to write is, his question is like this: can it be parabolic in another frame that moves with constant velocity with respect to the first frame? Then you can say yes. So, what is your answer for this? Yes, it's possible. Possible in what sense? If the second frame of reference is similar to the first frame of reference, then you can find even that motion of that body as parabolic. If not, what can it be? That is a question he is asking you. If suppose the second frame is not an inertial frame, then it will be seen like a straight line path. So what is the correct option for this one? If both the frames of reference are similar, then one can find the path as a parabolic path. If not, the second frame of reference, when we see from that frame of reference, the body's motion will be along a straight line path. I think you might have understood the answer for this. I repeat once again. If the second frame of reference is also an inertial frame, then the path will be parabolic. If it is not so, then the path of the body will be like a straight line path. That's all you have to give, 2 sentences. This entire description you need not give. I repeat once again, if the second frame of reference is also similar to the first one, that means what? If the frame of reference is exactly similar to the first one, then we find that one like a parabolic path. If not, it will be like a straight line. That is the point. So this type of a question will definitely make you think twice before writing the correct answer for that. He is asking you, if not, what it can be. If it is not so, it cannot be parabolic means what? It must be a straight line path. That is the answer for this question number 9 as such of this chapter. Let us take the next question here. A spring with one end attached to a mass and the other to a rigid support is stretched and released. What is the magnitude of acceleration A maximum? When it will be maximum is the question. Observe this figure carefully. A spring is attached to a body of mass m. It is fixed at one end. At the other end, we have attached a body of mass m. Okay. Now, when you are taking, this is the position which is called mean position of rest of its center of mass. When you are pulling this one down to a point like this from A to B and leave it, then what you observe first of all, it used to oscillate in the vertical plane like this. That means it comes back to normalcy, goes up for a while, stops there somewhere, again comes back, comes down. That in the sense it oscillates in the vertical plane, up and down oscillations. These oscillations, we should call them as simple harmonic oscillations. That anyhow you also know that one from lower classes. So remember carefully, whenever a body is in simple harmonic motion, with respect to its mean position of rest, then what is understood? At extreme position of the body, acceleration of the body is maximum. I repeat once again, when a body is in simple harmonic motion, at its extreme position, acceleration of the body will be maximum. That is the concept. That means what? This is one extreme for this body, this is the other extreme for this body. It's now oscillating in between B and C. So, whether you take this extreme position or this extreme position, the acceleration of the body is said to be maximum. So, what should be your answer for this? At the extreme position, acceleration of the body will be maximum. I repeat once again, at extreme position B or C, the acceleration of the body will be maximum. That's what he is asking you. Where the magnitude of acceleration will be maximum, that is the question. So acceleration is always maximum at extreme position. And if suppose they ask you at minimum, where it will be minimum? Minimum means while crossing the mean position of rest, it can be taken as minimum. So two statements you people should remember. At extreme position, acceleration of the body is maximum. While crossing the mean position of rest, the acceleration of the body is minimum. These two are the points. If you remember, first one itself is the answer for this question number 10. So write simply, at extreme position of its oscillation or oscillatory motion, the acceleration of the body will be maximum. That is the concept. So this is the question number 10 what has been given in this particular chapter. In fact, they have given 10 questions in the exercise as far as motion in a straight line that is concerned. All the 10 we just have taken up, but the cases are to be dealt with carefully. No need for you to write maximum like pages together like the answer for that. Just 2 sentences for each answer is enough for you.